Oh, welcome back to the panel discussion. We have a few more panelists. Apart from the speakers, we have Arup Mandal, Dr. Arup Mandal from RGCI. He's the director, selective breeding. Uh, Welcome to the panel, Dr. Mandal.
Thank you. Thank you.
And we also have Director Technical of Coastal Aquaculture Authority, Mr. Anthony Xavier. We welcome you, sir.
Thank you so much, President AISHA, for the great opportunity.
Thank you, sir. You're welcome. And we also have our own colleagues, our General Secretary, Dr. Joshi, and our Vice President, Mr. Muthukarappan. I mean, without their support, we would not have put this webinar together. And there are a lot of questions. Probably we cannot take all the questions. Few important questions we'll take. I mean, there is one question, that is making rounds. I mean, if you look at Indian shrimp farming, it is a very, very fragmented farming. I mean, probably there is nowhere in the world it is as fragmented as this. The average size of the farm, if you see, it could be less than 5 hectares, definitely. In few areas it's less than 2 hectares also. So that is one thing. So we cannot have a real foolproof biosecurity, And the point number 2 is, in fact, Robin's touched upon this. I mean, the farm density, the density of the farm is very, very high. There is an explosion of shrimp farms in most of the areas where shrimp is cultured in India. So, I mean, we're going beyond the carrying capacity of the source water, and we have lack of biosecurity. I mean, biosecurity is definitely not foolproof. And what we tend to think is the stocks what we're bringing in, they're more suitable for indoor or semi-indoor kind of biosecure farms, but we don't have that kind of farming structure. So how do we go about what the breeding companies have to do to help our farmers thrive? I mean, I would first ask this question to Mr. McIntosh. Robbins.
I'm not sure there is any one answer, but I can say this, the stocks that are going into India today, there's just so much you can do. A lot of it is up to the farmer. But if we look at Ecuador as the example, the Ecuadorian, you've made emphasis of the Ecuadorian and robustness, but if I put an Ecuadorian shrimp in an intensive shrimp farm, it's not going to fare very well. I've done that, not in India, but in other places. So and in fact, it oftentimes fares worse because it carries subclinical disease or pathogens, and the stresses of the systems bring it out. So there is the issue is with stresses, and with success, basically creating more stresses. So where does breeding take us? Well, I do like Robin's approach, where basically let the families decide which ones do well and concentrate on those families. And if you can improve the growth, then you improve the growth. You select again for size. So in terms of my own program, I think that needs to be added into it, another dimension, to let the animal tell you which ones are going to do well, because we do have a large diversity within the program, but a program and diversity is only as good as you know what to select. And so with robustness, that's a whole nother characteristic that has a loose definition, and how you define it and how you select it is at this point, I think, difficult. The best way is to use the natural environment to select, like API is doing. The more efficient way is if we could find a way in the laboratory to select, where we can do many more families and do much more intensive selection. So eventually it'll be a combination of things. But I do think the moleculars will play a growing role in identifying these families that do well, and try to combine the growth with robustness in a very stressful condition. This is going to be a challenge. Can it be accomplished? I like to think that anything can be accomplished, but I can't tell you how that will be accomplished. Right now, we've got lots of stresses in the environment. and those stresses have to be accounted for. Anything the farmer can do to reduce those stresses will help. As Robin said, oxygen. With these faster growing, higher metabolic strains, it takes higher oxygen to keep them healthy. If you can keep your oxygens above 5.8, 5.9, you will reduce white feces and EHP. But if your oxygens go below that with these stocks, your EHP will explode. And that is what happens. So again, the farmer can do some things, but unfortunately, just the general environment have deteriorated, and it's hard to reel that backwards, but that should be cognizant.
Okay. Robin, your take on this?
Thank you. So I have to make a confession on this. So when we set out to do this, I mean, we just wanted to get good survival, and we have tested the Dragon line as something that we developed in China. Because our animals do grow slower and the fecundity is worse and all these things. So we try to find better animals that can do this and improve the program. So when we set out in, I think it was 2020, we tested over 100,000 animals in China, different conditions. Actually, we genotyped over 100,000 animals in China. And to find that particular animal that did best within these really, really challenging environments, which everybody has challenges. And so that has really been the thing. We hope we're doing the right thing. I mean, you just never know until you actually put it on the field. But the responses that we're seeing, especially in Indonesia, on these animals, where farmers were just not able to get a productive stock at all, and they're actually they have pretty good infrastructure, and to see what the impact of these animals are is just absolutely incredible. And so this is all the result of testing at the farm level and testing within that particular environment. And I agree with Robbins. I mean, there's a combination of many different things that need to be done, but the information we're getting from the actual condition and it's so invaluable because things happen, as we all know, and it could be an algae bloom or it could be a paddle wheel goes down, and to find out the animal that can best handle that is the key for us, and it seems to be working.
Yeah, that brings me to the other question. I mean, somebody was asking, I mean, did you take the DNA samples from India as well? You have collected a whole lot of DNA samples, is what you told in the presentation. Somebody is asking, did you take the DNA samples from India?
So we've been taking DNA samples for years, and since we started operating our lab. So we have been primarily testing our own shrimp, but you do get other DNA samples from other stuff. But as far as a real program in India itself, we haven't really done that. We've done that in China, and again, my last visit there, it looks like we're going to really do a very intensive program in India. Hopefully, I can make an announcement in the next, I don't know, definitely by the event in June. But we're looking at working with some partners to do a very intensive, kind of like the Dragon program, but for India. So it needs to be done. I mean, it just again, these are things that work, and they're proven to work, and it's just something that there's no reason not to do this. And so and whether it's us or whether it's one of our competitors, we've been an open book. We've been saying since day one, hey, this is how we're doing it. We want to do, and so it's almost like hearing everybody with their strength and their focusing on the survival issue. It's really we've made an impact that way, and I think that's the way it needs to go. And once we get survival, I mean, I think as an industry, we want an animal that grows 1 gram a day, but with 90% survival. That's ultimately what we need to look for. And it's going to take time, but I think we can do that. I think we can do it.
Thomas, could you chip in with your thoughts?
Yeah. Yes. Well, it's always a challenge for us as a breeder to select animals for growing fast and survive good. I mean, that has been, when you go to the field and you ask, okay, what do you prefer, growth or survival? And I want both. It's always, I want animals that survive well, 100%, and that grows 0.30 grams per day. So I tell you guys, yes, that will be very likely, but you need to put some effort on that, and we cannot make magic with genetics. As farmers and hatcheries have you heard me? It's not.
Yeah.
Hear me well? Okay.
Yeah.
Farmers and hatcheries have to put their own effort also to give the animals the conditions to express their potential or genetic potential as well. I mean, it's case that we are doing our best to produce an animal that could cope from different environments and could survive well on different environments and growth well on different environments. But if the environment is not good enough to let the animal express the potential, there is nothing we can do. And we are not magicians. We are scientists that we work as based on science. And although we do all what we can do to help the industry, I think there is things that needs to be changed as well, as Robin said. The minimum biosecurity measures. Oxygen is very important. Fluctuations on pH probably is one of the most stressful factors. They have to change to look on that. Animal that grows very well, normally they have more molting sessions during the culture period, meaning that they have to give, or the water conditions need to be very well so they can build the shell very quickly before pathogens go in. So these fast growers also, they molt much more frequently. So they go through very stressful conditions more frequently than the slow growers. So that we need, for those animals, give very good conditions on the water quality and minerals as well to let them build the shell properly in a very short time.
Okay, thank you. I mean, that brings me to the second question. See, the major difference between shrimp culture today and like 5 years back is the EHP. Emergence of EHP. I mean, it has thrown spanner into the works of a shrimp farmer. And that could be the major difference between India and Ecuador. I'm not really sure whether they have this pathogen of EHP in Ecuador. So, I mean, can we produce some shrimp which could be resistant to EHP? Because that looks to be the major difference between India and Ecuador, or for that matter, Asia and Ecuador. That is bringing the profitability down, along with the change in microbiota. Most of the water bodies in India also, the microbiota has changed. So this EHP, along with this Vibrio loads, is wreaking havoc with the farmers. So can we do something about EHP? Is anybody working on EHP resistance? Robbins?
EHP is a very difficult disease.
Yes.
Basically, very few people work on it because it's difficult to work on. To do selection, it's a very long, it's not a quick challenge like white spot or TSV or even EMS. So it's very, very difficult. And we don't have the science going in to understand the mechanisms of the disease that we used to have for EMS. When EMS hit, everybody picked it up and started looking at mechanisms and looking at ecology, and then determining management for EMS became much easier because we understood the underlying mechanisms. EHP, we still don't understand that because it's such a difficult disease to work on. And frankly, there's just not very much funding available to work on it in the institutions that give us that underlying understanding. So that's one thing. Yes, I have invested over $1 million in an EHP program to try to find tolerance. But before you can do that, you have to have a satisfactory challenge to be able to look at it and understanding some of the mechanisms. My best understanding of the mechanism today, it's stress related. No stress, no EHP. Stress, the animal will succumb very, very fast. You say whether Ecuador, most of South America has EHP. They don't have disease, not stressed. I know of some specific farms that I won't mention, but they put animals in extensive, no problem. They put it in their intensive and they get shut down from EHP. The EHP is there, but in no stress environments, you have fewer problems. I remember having breakfast with a Thai farmer, and he was in the same canal as one of our farms, and we were dying of EHP, and he was showing these beautiful harvests and all of this, and he had to be exposed to EHP. And I go, how do you do this? And it's oxygen, he says. I keep the oxygen above 6. Then I go to our farm to check, what is the real oxygen? Well, they were closer to 5. So high oxygen, low stress environments, you don't get EHP. And so when you have an epidemic of EHP, two things have happened. There's so much EHP, you've totally infected the coastal environment. So you're always bringing in higher and higher levels of the pathogen. And two, the stresses have built up such that the pathogen is expressing itself in more serious and serious disease. It's a spiral, and it spirals out of control. So the first thing we should do with EHP is ensure the farms do not get reinfected from PLs. That's still happening. So that's the first thing we can do, is shut off the source from PLs. The second thing is, hopefully, if we can reduce the incident in the environment, we can start to get some control on this and emphasize stocking densities to match oxygen levels. If we can reduce stocking density so that our aerators can keep up and keep a high performance environment, we can go back to profitability. But if we insist on going higher and higher density without increasing aeration proportionately, we are dead. Second thing, in India, I don't know, but all the pictures I see in India, I see very few auto feeders. Auto feeders is part of biosecurity. By feeding small amounts throughout the day, we keep the bottoms cleaner, we keep the environment stronger and stresses lower. So it's not just about an auto feeder to save labor. Auto feeders save the environment, and you always get a positive response from auto feed. They're not expensive. I don't understand why more Indian farmers do not use it.
You nailed it, Robbins. And connected to this question, I mean, if we have lines which are tolerant to bacteria, can we address the problem of EHP as well? Because as you rightly said, it's because of the stress EHP is getting manifested. So if you have a line which is resistant to bacteria, I mean, the microbiota also has changed throughout the country, you know. So if you have a resistant line for bacteria, can we address the problem of EHP to an extent by going for lower densities?
I don't think that bacteria tolerance, impacts, and bacteria would be robustness, really. So we're talking about bacterial infections and robustness. There may be some, but it doesn't trump the environment. As I said, I can take Ecuadorian stocks. I can take the toughest stocks known and put them in an EHP environment and stress them, and they're going to succumb. They're not going to hold up. So EHP is a tough disease. It's the toughest disease we've faced. There is no simple answer in breeding. There's actually no simple answer in management once this environment has been deteriorated. But that's where we are today. And that's why we have 10% higher losses from EHP every year in every Southeast Asian country, because it's just building up in the environment. We have to start reducing it in the environment. That means clean PLs and reducing density.
Oh, we have a lot of take-home messages from your answer, Robbins. One thing is cleaner PLs and controlling the EHP in the environment and going for lower densities and maintaining good DEVO. I mean, have enough aeration depending on your density, and also start using auto feeders. You know, it's not just saving the labor, we can save the pond bottom as well and stop the animals, to get subjected to stress, and thereby, do away with EHP to an extent.
Let me tell one more story. Let me tell one more story real quick. So black tiger seems to be resistant, tolerant to EHP. It's not. I can bring down black tiger in a lab with EHP just like white shrimp. So I had a customer in China come to see me, so happy. Every one of his white ponds failed, but every one of his black tiger ponds succeeded, and all of his customers succeeded. And it was like the greatest revelation. And so I asked him, what's the density of the black tiger? Oh, it's about 25, 30. What's the density of the white shrimp? 300, 400. So I challenged him, put the white shrimp at 30 to 40. You will succeed with white shrimp too. It's not that black tiger is more tolerant. It is black tiger, by being black tiger, is low density. Now, when China goes to high density black tiger, guess what? It fails.
But, even Vaname at lower densities in India, we're not able to overcome EHP, Robbins. I mean, in India, if you look at the densities, they're only about 30. And this year we have come down to 25 or so. But we're not able to overcome EHP.
Well,
It
all I
looks
can
to be
say
very
is
sticky. It looks
the
to be very
environment must
sticky.
have really deteriorated. The environment must have really deteriorated.
But tigers are doing very well in the same environment. I mean, the ponds which have been affected with EHP for 4 or 5 consecutive crops. I mean, farmers have stocked tiger and they got bountiful crops, you know.
That same density. Well, interesting.
Yeah.
So if I may interrupt here. So
Yeah, please, Robin. I'm about to come to you.
Diseases, so we can focus on EHP, which is the disease du jour, and I'm sure 5 years from now we'll be talking about a different disease. And so diseases are part of what we do, and I agree with it. It's a very difficult disease to solve EHP because it just doesn't lend itself to the way other diseases do. That's why what we are doing by selecting the shrimp that survive in a pond. We don't know why. I don't know, why this particular family does better than the other one. So we're not really trying to figure out, what makes them so great. It just says, okay, this guy survived, this family survived, and for whatever reason, that's the one we're going to breed going forward. And one other thing that's really important about that is that when you're selecting within the pond environment itself for your next generation, then you're also probably pre-selecting for the next challenge that's coming down the pike, because right now there's probably a different microbe or different disease that we're not even aware of, that we're all going to be talking 4 or 5 years from now. And by pre-selecting season after season for animals that do well in this environment, they're probably already seeing that. So I think that as an industry, we have to acknowledge that these things are always going to be part of it. And only by selecting within the environment and doing the best husbandry that we can are we going to succeed. That's it. It's that that simple.
Dr. Xavier, you raise your hand, sir.
Yeah, thank you, Ravi. See, from this discussion, that what we are trying to say is that with the densities, probably with instead of in areas where you use vaname, higher densities, they have stocked tiger and got big crops. That is what some of the speaker is trying to say. I mean, it is not something new. It is also depicted in India, in fact, in Gujarat, where we had big crops. And we have people who were commenting that, and even Ravi commented that in India, we are not able to find a good crop, even at the lower densities with vaname. My take here is that, see, it is not the question of density alone. Probably it is the question of species rotation. See, when we were operating Saudi Arabia with the Red Sea Prawn Company, we were infected with white spot for monodon. In the same farm or in the same location, when we used the indicas, we had no problem, So I don't know, it is purely because of the density. My impression or interpretation would be, it is the species rotation which is proven, which has been proven in agri and other for husbandry sector, wherever the species rotation helps you to get a better crop. So my take would be here that we need more species, not just vaname, not just monodon. My question to the speakers here is that, why are we not thinking about Pinus indicus, which is equivalent and better species than vaname in all its traits, if it can be domesticated and selectively bred, so that you will have a basket of species like Pinus monodon, Pinus indicus, and L. vaname. Pinus monodon being a low density model, I don't think it will sustain the infrastructures that we are creating or such a robust development or progress in aquaculture. So we need a species which is much stronger in terms of traits, which is similar to the vaname. One more small, I'll take only 2 minutes to 2 seconds to complete. The other question to the panelist here is that, how do we comply or confirm the traits that we are claiming for different commercial lines? See, today, it was not there in the It was not there. These lines were not there a year ago or 2 years ago. Suddenly, we have so many lines coming into the commercial system. We are calling it with the different big names. Growth line, trend line. I don't know. There are so many lines. My question here is to the as a regulator of India, to the breeders, how come all these lines came up in just like that in a year or two? I don't understand. Even for a stock, somebody was saying it needs 7 or 8 years to get a proper line. So I just wonder how come these lines are there, and how are we going to confirm them or comply? End of the day, we need to do justice to the farmers. All the speakers concurred with that. But with these lines, lining up in the market, I find that we need to give some justification from the suppliers, that is the broodstock breeders. That's my take, Ravi. Thank you for the time.
Yeah, you're welcome, sir. Robbins.
Okay, let me on a couple of levels. Monodon and Van Amme. Yes, there are biological differences, and that's very true, especially when it comes to EMS. EMS will also kill Monodon, but Monodon is a picky eater. It needs fresh food. It goes to the bottom, and if the food is there for more than an hour, the Monodon won't no longer consume it. Van Amme is a garbage eater. It eats everything. It eats the waste, it eats old food, it eats shells, everywhere that EMS bacteria live. And that might be true with also the EHP spores. But they're very different in the way they eat. And that is a major difference in the two. And it comes to, yes, I fully agree. Monodon is going to have a hard time replacing Van Amme because of the productivity of Van Amme and the infrastructure that Van Amme has brought with it. But on a side note, one of the things that we are doing is looking whether at super high densities, if the behavior of Monodon breaks down. And we certainly see a breakdown of behavior when you change density. So, low density 20, 30, they do well. If you go into middle densities, 50 or 60, 70, they don't do well. What happens when you put Monodon at 200? I have some evidence that it breaks down and it starts performing normally again. At much higher density. So we're looking at whether there's some density behavior as well that can be applied with using the Monodon. But right now, I think the biggest behavior difference is Monodon is really two-dimensional, and it basically is a very picky eater. Van Amme is more three-dimensional, and it will eat anything. And that's good and bad. Now, on the, what was the other idea we had? There was another
He was asking about indicas.
Indicas.
As a candidate.
For me personally, 2 species is enough because every species takes a lot. The rise of different lines. The CP Kong did not rise instantaneously. I've been working on that for 6 years. Okay, I only commercialized it 2 years ago, but it was in 6 years in development. It was a long term, and the reason it was developed was for those ponds that couldn't be biosecure. That was developed mostly for a South American audience, other audiences that may have less ability to keep good biosecurity and good conditions. But for most of Asia, Thailand, Malaysia, Vietnam, Philippines, India, the main line turbo, and turbo is a line that changes all the time based on the indexing we do. There was a question of how you can select for 2, 3, because there's negative correlations. You have many, many families that you are selecting on an index, and there's compromises being made so that you put the index of what you think is important. Right now, survival is a higher part of an index than growth because that's what the issues are. Robustness will be a higher component of an index than growth. And so you basically change the index as is required by the farm. I don't develop a new line. I basically change indexes. Again, Kong was developed for low biosecure situations that needed white spot tolerance. It was not developed for Southeast Asia, where we've learned a higher degree of biosecurity. The Bolt line was developed over 4 or 5 years strictly on growth, very low tolerance for indoor systems of the United States and Europe, where there's perfect biosecurity and we do not have disease. So these lines arise as needed, and they're not instantaneous. It takes development time. You don't hear about them until they're ready for the market.
Well said, Robbins. And Thomas, would you like to chip in? We didn't hear from you on these questions. Yeah, please.
Yes. Okay. For EHP, let's start it. Yes, I agree with Robbins. It's a very complicated disease. We spent many time trying to develop a proper challenge test to challenge the families. Sometimes they got infected, sometimes they didn't. So it's difficult. But I will share some experience I had with that. Well, we had a farm where we are testing our families, and they were infected by HP every single time we send them. With the fields where the family were clean, but they got infected. So we were happy because we could use this as a proxy as selection, and we did it for 3 generations, and it seems that it works well. However, the farmer was not happy, so he had like he has a earthen pond, so he lined the ponds, and they have recirculation. He have a sump tank. He lines the ponds, and still the HP was there. Even though he can clean the line pond very well, HP was there. So we actually advised him to avoid the sump tank where he was doing the recirculation. Once he avoided the sump tank, HP was over. So it seems that HP needs a high organic matter, a lot of conditions, a lot of dead points to develop as well. If you have good environment and you manage your feed correctly, and you don't have sludge, a lot of sludges or dead points in the farm, probably HP will not be a problem. Just by doing this, the HP disappeared. He was happy, I was not, because that avoids me to check my family for HP. But developing challenge test for HP is very complicated. I agree with Robin. We select for survival as well. It seems survival is a proxy of robustness. You never know exactly what it is there. We try to give them very tough conditions in one of the ponds, so they express the survival or the genes are expressed on the genes that involved in survival and robustness could be expressed, and that gives us an advantage over other companies that they don't test in challenging conditions. On different species, yes, every time it's to a new species, you need time to develop. You first need to domesticate it, know the biology of the reproduction. It takes a long time to do that. So just with start selection, you need to domesticate and control breeding, and that's the stuff. And once you do that, you can start thinking on genetics. So that's why I think indicus or people with haven't been able to do that. It takes time, it takes money. You don't know exactly how well they will sell. So I have experience with Atlantic Code, that we start a breeding program in Atlantic Code, and we, after spending millions of dollars on a breeding program, we wanted to sell it, and the industry was not there. Nobody bought the fingerlings because they were not a cod industry. So if we want to develop a breeding program for a new species, we need to be sure that the industry and the business is there, because we cannot spend $1 million and not selling it. I think it's one of the factors of working with other species. We have to be sure that it will be able to sell. And the lines, I agree completely with Robin. I think that when once a company launch a line, is because they have been working in that line for many years. We are working on resistant line for many years. We haven't even launched it, but it's there. We are trying to develop it and select for. We haven't everything for many generations, but it's still not ready to be launched into the market. Once it's ready, we will launch it, but it's not ready yet. So that's the case, I think, for many companies.
Thank you. And one more question to all the panelists. I mean, when we started importing the brood stock like 10 years back or 12 years back, I mean, we used to get about 8 months old animal, 9-month-old animals. Now the animals are growing so fast. What we're getting is like, 4-month-old animals, sometimes even 3.5-month-old animals. They're attaining the size of 40 grams. And we get to think probably we're getting animals which are premature, I mean, if you're sending animals of 70 grams and 80 grams, there'll be huge mortality on the way and all that. And even handling those animals in the maturation could be a difficult thing. So how do we, kind of solve this issue? I mean, and the first question is, I mean, whether are these animals premature? I mean, 3.5, 4-month-old animals are premature. I mean, they're attaining the size. The other thing is, if they're premature, how do we handle the situation? Robbins?
Can only talk from CP. But our animals have changed. The genetics change animals. And one of the things that changed was maturation. In the old days, we assumed size equaled maturity. So you had that 40-gram level. And so as they grow faster, we reach the 40-gram level at an earlier age. And now I think the understanding is it's not size related, it's age related.
Yeah,
so you're also correct. With these fast growing shrimp, if I grow my shrimp to the age of maturity, and for me, the age of maturity, and it's male limited. So females mature earlier than males, but males don't mature until 180, 190 days. And at that, if we're growing them at optimum for 180, 190 days, you're right, they would be 90 grams. And you're right, the first reaction of maturation is you're sending me an old animal. The second is it takes two hands to handle it, and they don't want two hands, they want one-handers. So now we've got the dilemma of we've got a maturing animal that matures at a size that's too big. And I'll just leave it at that. There are solutions, but I'll leave it at that.
You don't want to disclose your trade secrets. Good. Proprietary. I respect it. I mean, other speakers? I mean, Robin, your thoughts on that?
I can make a comment
because
on this.
This is a major issue, I mean,
yes,
for the hatchery operators, it's a major issue, especially for Indian hatcheries, because, I mean, we are far off. I mean, transit time is long, and then we have to keep them in the quarantine. If you are bringing bigger animals and keeping in the quarantine, the mortality is going to be high. Then again, it goes from the quarantine to the hatchery. That takes quite a long time, if the sizes are big, there are mortalities. And then again, post-stocking mortality in the maturation, and then handling, So all these issues are there.
So my point on this and my answer is this, and I'm glad Dr. Xavier is there to listen to this. I think that India has created an artificial barrier for no reason. India is really the only country in the world that has this quarantine center. And unfortunately, because of the quarantine center, the industry tends to focus on fecundity as the most important thing, because they have X amount of cubicles and I need to get X amount of knobs out of my spawns, out of my cubicles. One of the reasons why API has not broken through in India as it has in other countries is because this artificial barrier is there. Other countries, we want to sell 10,000 animals, we can send 10,000 animals, it's not a problem, because yeah, the APIs have lower fecundity. So by having this quarantine center, I don't know why it's there, but it is adding an artificial barrier to the thing. So if Sayako wants to sell their breeders and they want to sell younger ones or even older ones, that constraint shouldn't be there on how they're going to pack and how they're going to ship and the age that they want to ship it to. And this cubicle is very much affecting that. And that's something that I think that the Indian industry needs to look at, because Ecuador doesn't have this constraint, Indonesia doesn't have it, Vietnam doesn't have it. So there's definitely something there we need this disease inspection, but there's other ways to handle this. And I think that it's adding an artificial barrier to your success, because some stocks are not getting in, or other stocks are being optimized for the quarantine, not necessarily for the farmer's end use. So that's my point.
Thomas?
I also agree with Robin on the age. I think 6 months should be the time, the minimum time that animal should be produced as a breeder. And again, if we would grade them in size that we should raise normally, it will get 70, 80 grams. What we do is actually reducing, we is a point where we restrict the feed actually in some way. And that gives you much better control on some of the parts. It's you need to manage the way to let animals grow. Otherwise, they will be too big. So our animals are 6 months. We put that in our SOP. We cannot send any animal that are below 6 months. Otherwise, it will underperform. If we do that, we have to talk with the customer and say, okay, Mr. Customer, those are a little bit younger than we expect. You need to grow them for X time in your facility. If they accept, we do that. If they don't accept, we have to wait. I prefer to wait, but I don't want to sell or to send underperforming animals. That will save myself, but it will kill my business. So we need to be sure that the animals that we send are performing well. And again, I agree with Robinson. Males are the limited factor. If we send 4-month males, they are precocity. They do not develop the sperm, and the mating rate will reduce a lot. So that's important.
Okay. One last question from my side, then we'll take more questions from my colleagues. And if you look at one difference between Ecuador and other Vaname farming countries, I mean, in Ecuador, it's the indigenous species, whereas you look at all Asian countries, it's exotic. I mean, is it having some effect on this, on the failure of, shrimp farming in other countries, failure or relatively less success than Ecuador? I mean, is it playing a role, Robbins? I mean, it looks like that. Apparently, it looks like that.
Basically, we're talking about diversity, heterozygosity, things like this.
Yes,
and you would expect that to be higher in Ecuador.
Yeah,
it's not. Ecuador has also domesticated and programmed their shrimp such as to narrow the diversity and reduce the heterozygosity. However, there are a number of programs that have done a very good job of maintaining diversity and heterozygosity outside of Ecuador.
Okay.
And so it does exist outside of Ecuador, outside of South America. And it does not necessarily state that just because you come from Ecuador that you have high diversity and high heterozygosity. So, but yeah, I mean, it's certainly, if you don't manage correct, you can destroy it very quickly. But again, as I think Thomas mentioned, we look for mating animals that are distant, not close. And so the primary characteristic in the genetics program is not based on some characteristic like growth. It's based on relatedness. And we're minimizing relatedness in the genetics program. On the commercial level, we're maximizing attributes like growth and other stuff. But more important than that, at the genetics level, is distance. So as we do not get a total loss of diversity as we breed certain characteristics.
Thank you. Dr. Alok Mandal, would you like to ask a few questions? I mean, he's from RTCA, he's Director Selective Breeding in Rajiv Gandhi Center for Aquaculture, which is an arm of MPDA. Dr. Mandal.
Yeah, thank you. Thank you for giving this opportunity. And first of all, we all know that selective breeding is all about keeping right balance. And all the three speakers today, they talk about this only. What I find out, the basic thing is genetics and health. And particularly, Robbins told in his presentation very nicely about this health and breeding program or genetics. And if you look at our Robin Pearl's presentation also, it was also almost the same line that survival. He prefers survival than growth. And finally, of course, being a geneticist, I also support our Thomas, because he very nicely told more than it is important the balance line than that of so many lines and all. But one thing I just mentioned here, I'm not agree with Robin Pearl when he mentioned about that artificial barrier. And he mentioned Ecuador and India and the major difference between these two success, one success and one failure, of course, because of this artificial barrier. I would rather support the view of Robbins, who told that the environment, that density, that biosecurity, then clean PL, all these things are actually playing a major role for getting the success. That's only I want to say. Otherwise, all the presentations are superb, and we learned a lot from all the presentations. Thank you so much.
Thank you.
Thank you.
Joshi, are you there? Dr. Joshi? Muthu?
Yeah, yes. Ravi.
Would you like to ask some questions? I mean, what the participants
Just
have
one
asked?
question. One question. Is
Yeah,
it
go ahead, please.
is it time enough that instead of talking of all these pathogen-free lines, is it time enough that in India we work on tolerant and resistant stocks?
Yeah, Robbins.
Yeah.
Go ahead, sir.
Robin, sir.
Tolerance is a genetic characteristic, has nothing to do with health. In the past, people thought that they could get the genetics by exposure. And that's true, but you're also compromising the animal by putting potential pathogens in farms. Again, the history that I see, it's fine for extensive, it's fine for semi-intensive. But once you go to intensive and you compromise the animal with a pathogen and you put it into an intensive stressful condition, it very well is going to come back and hurt you. Genetics, on the other hand, when we look at white spot genetics tolerance, EMS, APENS tolerance, TSV tolerance, we're not exposing the shrimp to the pathogen. We are looking at the genetics and then how those genetics pass on and create higher and higher tolerance within the animals without exposure. So you do not have to have exposure to get great tolerance. And to me, that's the more scientific and the preferable way of doing this than to go throw a bunch of animals into the pond and let them self-select themselves. And when you collect them, hope that you don't have any pathogens in the animal.
Thank you.
Yeah.
Robin?
I-
Any? Thomas, yeah, you can.
Yes, I agree with Robbins. I mean, the genetic factor or resistance of tolerance is innate of the animals. And without healthy animals, it's going to be very, very difficult to produce healthy PLs. And I learned that by that. I mean, when I was working in South America, they SPF was like hell. Nobody wanted SPF because once they reached the pond, they all died. But they also have very, very unhealthy broodstocks in the production. So the mortality in the maturation were very high because the animals, even though they could check negative for PCR, they were horrible looking in the maturation. PCR is a nice tool, but they don't ensure you to have clean and healthy animals. You need to have a complete surveillance and management system to have healthy animals. PCR by itself do not produce SPF or healthy animals. You need to have a complete system to clean and healthy animals to have clean PLs. Once you have that, you are much, I mean, the success probability is much higher than having unhealthy animals, even if they test negative for PCR. But you see, your animals in maturation, they are horrible. They have a lot of, they are dying. They have diseases, but they test and they are negative. So you are happy. You don't be happy. You shouldn't be happy. You should have animals that are coming healthy to your maturation, and you need to keep them healthy. Otherwise, I mean, all the paradigm of SPF will be completely destroyed. And yes, grain resistance, it's now very, very likely with genomic selection. Genomic selection is going to be the breakthrough on genetics and selective breeding in aquaculture. We have many possibilities with the genomic selection because you can actually use healthy animals and select on the individual basis. Before we have, or people had to use survivors. It's not the case anymore with genomic selection. We can use survival-like animals and you can keep them clean for many generations. That is going to be a breakthrough on disease resistance in aquaculture.
So if I may add to that,
please, Robin.
Yeah, respond. So, Dr. Mandel, I respect your position on the RGCA, but I believe one of the main focuses is not to bring diseases into India, and all we've been talking about is diseases. So, diseases are there; they're going to be present. They're going to come in, and one of the things we've done that we're talking about is how do you find the optimum cross? Genetics is a numbers game. The more you can test, the more you can do. And so, for instance, in China, we brought, tens of thousands of animals across. If I want to bring tens of thousands of animals to India, how am I going to do that? I can't. It's just the quarantine center acts as a barrier, and so that's why I mentioned it's not allowing us to bring the degree of testing, the intensity that's needed to develop that next animal, and I think it's very much needed, and I think it's something that again, I agree with a quarantine center to make sure we don't bring diseases, but so far, it's if we can find a way to bring lots of animals into the country and have that tested done, then I think that there'll be a much greater benefit to the industry over the long run.
Robin, you seem to have opened up the Pandora box,
Can of
worms. You came up with a good point, it calls for a separate discussion, we can have a good brainstorming discussion on this quarantine, we also have other issues, definitely it calls for a, discussion, and you opened the Pandora box, any more questions? Any more questions from the panelists? Dr. Joshi, are you there?
Yeah.
Please go ahead.
One question. It's thank you for all the presentations, very good session, good presentations you have done. And as a hatchery operator, I have just one question. See, Robbins has been talking about the trade for growth. The shorter the culture, the faster the growth, it will be better like that. And Robin Pearl was going for the survival aspect only. Better the survival, you make money. And Thomas was talking about the balance, the approach. So as a hatchery operator, in the present situation, which line should I supply to my farmers? In the present situation.
Oh, that's easy. That's easy. No, just kidding.
That's only API. Robbins, you are not there. You're outside, or you can come up with your.
Let me define the CP program again. Dead shrimp don't grow, so we only emphasize growth in shrimp that live. If they die, it don't matter if they grow fast. Okay, we've done that from the very, very beginning. So I know I've been known as the fast grow, fast die guy. But the fact is, I know very well that if they die, they can't grow fast. And if they're growing fast, they didn't die. So yes, you have to balance. I think we all talk about balance. Is where we balance it. And in my case, as I said, I work with indexes. Sometimes the index, when there's no disease and survivals are high, it's slanted to growth. And that was the case for 6 or 7 years. But then when EMS came, it got slanted to EMS tolerance. And then right now it's slanted to something else to take care of where the shortcomings are. There's very little emphasis today on growth. It's mostly slanted toward robustness because that's where the greatest gains can be made for the farmer. But I also agree with everything that Thomas said. Basically molecular is the future. Individual selection is so much more powerful than family selection. And when we're doing diseases, in the past, we've had to use families. And now, if you've got the right tools and you have to create the SNP chips and the markers, and that's another challenge, but you create these markers. Now we can go individuals. We can go, it's hugely powerful. It is a game changer. And that's the future. I'm not sure a specific disease is going to be robustness and do away with all the issues we have with challenging environments. So there is some responsibility still with the farmer to think about the environment, think how we can moderate and not overextend ourselves in the environment. But I think all the breeders understand that dead shrimp don't grow.
Correct.
You nailed it again, Robbins, and I'm afraid we have come to an end, and it was such a wonderful session. We had fantastic talks from all the three speakers. Our request to you is, see, we can learn from this animal also. It swims against the tide. It's a great fighter, our animal shrimp.
Yes.
And we would request you to sharpen that fighting ability of this animal and help us tide over the crisis. We will try to do our best, and we'll keep our communication channel open. We'll try to engage you more, and you try to engage us. You send the communication across, you drive it through the hatcheries and the farmers, and I thank each one of you, for taking time and doing a